Hello everyone, and thanks for watching Edupedia World videos. So we have already covered a part of theory of chemical equilibrium, and now it's our turn to move on to some numerical examples and mathematics. Okay, so see, ultimately the theory part of this chapter is pretty simple and pretty straightforward. The problem is in solving questions. So in the next few sessions we are trying to learn how to solve the questions using the theory that we have already studied so far, and what else do we need to study so that we are able to get all the numerical questions that might come in our examinations. Right, so let's look at something. Okay, some examples of what we studied in the last session. Okay, so in the last session we looked at algebraic operations on equilibrium constant. So let's see how we can use that in the questions. So let's take example 1, where we have a reaction N2 plus O2, okay, reversibly forms NO2. Okay, the reaction has been balanced and given to you in this form. Right, so let's say that at a particular temperature T, the equilibrium constant for this reaction is 100. Okay, so now you can be asked, okay, a simple one marker question can be, and even for like JEE mains you can have a simple straightforward objective question. Okay, so what is the equilibrium constant for this reaction? Okay, so this can be the first question. Alright, so see here, what is happening is you have basically reversed your reaction. Alright, that is, initially the reactants were N2 and O2, now they have become products, and the product was NO2, which now has become reactant. Right, so K for your new reaction is simply N2 O2 whole square divided by NO2 whole square, which you can clearly see is simply equal to 1 by K equilibrium. Alright, where K equilibrium is given to be 100. Okay, so this is always true. Whenever a chemical reaction is reversed, its equilibrium constant, new equilibrium constant, is simply the reciprocal of the original equilibrium constant. So in this case your final answer will be 1 by 100 or 10 to the power minus 2. Alright, so it's as simple as that. Let's say if in the same question they might ask you another part, find the equilibrium constant for this reaction NO2 going to N2 plus O2. Right, but this time the balancing is slightly different. Okay, so what has happened is, from the original reaction, okay, if we start from the original reaction, so this time not only have they reversed this original reaction, alright, but they have, after reversing the reaction, it seems like they have multiplied with a factor of 1 by 2 on both sides. Alright, or you can say they have divided the reactions on both sides by 2. That is how you get this final reaction. Alright, so first you reverse your original reaction, so you get this equation. Now you multiply this whole equation by a factor of 1 by 2, so that you get this final equation. That means I am simply writing K as K1. Okay, let's call this K1 and let's call this K2. Then I'm simply writing K2 as K1 raised to power 1 by 2. Right, if you remember, whenever we multiply the chemical reaction by a factor n, the equilibrium constant is simply raised to that factor n. Right, so here the factor is half, so the new equilibrium constant is simply 1 by 100 raised to power 1 by 2, that is the root of 1 by 100, which should be 10 to the power minus 1. Alright, so 0.1 is your equilibrium constant for this new reaction. So these are the kinds of question which might come based on that. Let's take another example, a very quick example, okay, and see if we are able to solve all the questions of such kind. Okay, so let's assume that you have been given two reactions. One of them is NO reversibly forming N2 plus O2, Okay, and the balancing has been given in this form. Alright, you are given K1 for this reaction, and you have another reaction for which you have been given K2. Okay, so these are the two equations which are given to you in the question. Now a simple straightforward question might come in your school exam, or if not school exam, then probably in JEE Mains you can directly get such kind of questions, that find the equilibrium constant for the third reaction, which is represented as follows. Okay, so here you have three reactants which are reversibly giving you the product. Okay, and your goal is to calculate this equilibrium constant K3 in terms of K1 and K2. So how can we do that? So see, in such kind of question, focus on your final reaction first. Alright, the reaction for which you have to make the calculation, which is the third reaction in our case. Okay, so in the third reaction I need nitrogen, oxygen and bromine on my reactant side. Alright, so somehow I have to manipulate the two given reactions, that is reaction 1 and 2, in such a manner that I will get these three components on my reactant side. So how can I do that? So it's pretty simple. What you are basically doing is you are taking, okay, the reciprocal of K1, or to say that you are reversing, okay, you are reversing the first reaction and then adding it with the second reaction. Or the other way of looking at it is you are going to subtract the first reaction from the second reaction, so that N2 and O2, which are on the product side, can come on the reactant side. Also, you can say that you are subtracting the first reaction from the second reaction so that you can eliminate NO. Alright, if you see, okay, if you see your final reaction, there is no NO in it. That means I have to eliminate NO from my first two reactions. Also, the NOBr is on the product side. Okay, so I have to maintain NOBr on the product side while eliminating NO. Right. So now you know that what you are going to do is you are going to subtract the first reaction from the second reaction. That is, I am going to do this, okay, this algebraic operation 2 minus 1. But another thing to note over here is that it's not just N2 and O2 which I need on the reactant side. I need them with a stoichiometric coefficient of half. Alright, so in the first reaction they have a stoichiometric coefficient of 1, which needs to be replaced by half. That is, I need to multiply my first reaction with 1 by 2. Okay, so I don't just need to perform the algebraic operation 2 minus 1, I need to perform the algebraic operation 2 minus 1 into half. Okay, so this whole thing is to be subtracted from second reaction, and that is how NO will be completely eliminated. Okay, because here there is a stoichiometric coefficient of 2 in front of NO, so if I multiply it by half, it will become 1, and now when I subtract 1 from 2, NO will get cancelled. Okay, so if I do this, if I perform this, I can get my resultant reaction third, okay, by performing this operation. Alright, so what you are going to do is you are simply going to multiply this by half, so that this 2 over here is gone. Okay, a half comes over here, a half comes over here. Okay, and then you will subtract the first reaction from second, so NO will get cancelled, and this N2 and this O2 will be subtracted from NOBr, and then you can shift them on the reactant side to make them positive. Okay, basically, okay, by performing this operation you are simply getting the reaction 3. That means reaction 3 will have an equilibrium constant K3, okay, such that K2 is divided by K1 raised to power half. This is going to be your final answer for K3. Alright, K2 divided by K1 to the power half. Why have I raised the K1 to power half? Because first reaction is multiplied by 1 by 2. right? And then this new reaction which has been multiplied by 1 by 2, okay, this new resultant reaction is now subtracted from second reaction, so that is why K2 divided by root of K1. Okay, so whenever you subtract two reactions, the equilibrium constants get divided, right? So these are how the questions come. Okay, they are pretty simple. You just need to know how to use the theory that you have studied. Okay, just look for what you need on the reactant side and what you need on the product side, and then accordingly manipulate the given reactions to get the required reactants and products, right? So in the next session we'll look at some more mathematics and then move on to some more numerical examples of equilibrium constant. Okay, so until next time, and once again thanks for watching Edupedia World videos.